Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. Today Muhammad Zarizun will present our group database project. This is our group members. First we got Ahmad Anas, and then we have Adib Farhan, Ahmad Pangeran, and last we have me, myself, Muhammad Zarizun. Part 1, we will look at our ERD. So basically our ERD got 4 entities, which is customer, ticket, staff, and booking. And then we go to the business role. Our first business role is a staff may handle one or more ticket. A ticket handled by a staff. Number 2, a customer may given one or more ticket. A ticket will be given to a customer. Number 3, a booking refers to one or many ticket. A ticket will refer to a booking. A booking is based on one or many ticket price. A ticket price will be in a booking. Next, query and output of query. First of all is SQL data manipulation language DML. Insert, update, and delete statement. First, we get insert statement. First is we insert into customer table based on customer ID, customer name, and customer. Next, insert into staff table based on staff ID, staff name, and staff word. Then insert into ticket price table. We insert into ticket price table based on price ID, price category, and price. And then we insert into booking table, which is based on the book ID, book date, and price ID. Thus, we will insert into the ticket table, which based on the customer's ID, staff ID, book ID, and ticket time. Number 2, we got update statement. Our first query for update statement is change the book date with book ID B11 to date at 25 August 2022. And then this is the SQL. Number 2, we want to change the customer name using customer ID. Then this is the SQL. And then for the query 3, we want to change the price based on price ID. Then we want to change or update the book date and price ID of booking based on book ID. And for the query 5, you want to change the cust name and cust phone of customer respectively. For number 3, we got delete statement. For query 1 for delete statement, we want to delete all the row in the ticket table. Then we want to delete all booking ticket that handled by staff based on staff ID. Next, we want to delete all the booking that handled by staff based on their staff ID, and that all booking that made by customer based on their cust ID. Then we want to delete all the ticket that available based on ticket time. Finally, we want to delete ticket that has been booked based on their book ID. Then for number 2, we got SQL data manipulation language DML, relational algebra, and select statement. For the first, we got selection and projection operation. For the first query, we will list all the booking detail that price ID is P03 in booking table. So this is the SQL statement, rational algebra, and the output. query number 2, we list all customer detail that number phone start with 01 and end with 8 in the customer table. This is the SQL statement for query 2, RA, and this is the output. For query 3, we will retrieve price ID and price category from ticket price table that the price is less than 9. So this is the SQL segment and relation algebra, and also the output for retrieve price ID and price category. For query 4, we will retrieve customer ID, staff ID, book ID, and ticket time, and rename the column as ID and details. So the SQL statement and relational algebras, and also the output. Last, for query 5, we will retrieve the price detail that ID is P02 and category is children and the price is 6. Next, aggregation and grouping operation. Query 1 is to retrieve the total number of tickets booked by the customer. SQL statement like select count book ID as my count from booking. And this is the output for query 1. For query 2, we will retrieve the number of tickets booked by each customer. The SQL statement will select customer ID, count, as book ID, as quantity, from ticket, group by customer ID, and order by customer ID. This is the relational algebra, and the output. Query number 3, we will retrieve the total sales. SQL statement will select sum ticket price dot price as total sale from booking in a join ticket price on booking price dot id booking dot price id equal to ticket price dot price id. Here the output and the DRA for query number 3. For query number 4 is will retrieve the total price that is booking. So this is the SQL statement which select booking.bookid sum ticket price over partition by booking.bookid ticket price as total price. From booking in the join ticket price on booking.price id equal to ticket price id, which lead to this output, and this is DRA. For query number 5, it will retrieve the total number of customer the staff should handle. This is the SQL statement for the query 5, which leading to this output. Number 3, we get inner and outer join operation. For inner and outer join operation for query number 1, we will select all the table in staff table, booking table, and ticket table. SQL statement, we select A, B, C. From staff A, booking B, and ticket C, where A dot staff ID equal to C dot staff ID and B dot book ID equal to C dot book ID, and order by A dot staff ID. This is the output for query number 1. For query number 2, we'll list all the customer name, the ticket time of all client, and sort it based on the customer ID. So the SQL statement for query number 2 is like this. And this is also the relational algebra and the output. Query number 3 is list the book ID, date of the booking, and the ticket time for rent. And SQL statement will be select book ID dot book date. The SQL statement will be select book ID, book date, and ticket time from booking, natural join ticket order by book ID. Also, the output and the RA. For query number 4, we will list all the booking with their price and price ID, time for the ticket, and staff who handle the tickets. This will be the SQL statement for query number 4 and rational algebra, and also the output. Last, for the query number 5, we will list all the booking with their price and price ID, time for the ticket, and staff who handle the tickets. And then this should be the SQL statement, RA, and the output. Last but not least, we have nested and subquery operation. For query number 1, we will display customer ID and customer information that customer name is relative. SQL statement will be select customer ID, customer from customer where customer ID equal to select customer ID from customer where customer equal to relative. And the output will be like this. For query number 2, we will display price ID and book date information for the book ID is B09. The SQL statement will be select price ID, book ID from booking, where price ID equal to select price ID from booking, where book ID is B09. Also, the RA and the output for the query number 2. For query number 3, we will display ticket price, information which price ID and price category that price is more than 7. For SQL statement is select price ID and price category from the ticket price where price ID equal to any select price ID from ticket price where price more than 7. This is rational algebra and the output for query 4. And query 5, we will display the booking ID and the price ID which price more than 10. SQL statement should be like this, and this is the output and also the RA. Lastly, for the query 5, we will display all customer ID, custom that should be handled by staff, which S01. And this is SQL statement for query number 5 and rational algebra, also the output. Lastly, for the conclusion, for contribution, a project named Zoo Enterprise was established to store the payment of zoo tickets and record data of the customer. This website also can make the work of the manager and the staff become easier because they can manage the payment and track down total number of customers there should be in the zoo at one time. Any zoo must have this kind of project since it helps customers in buying online tickets. This website can book the zoo tickets from anytime and anywhere as the website is an online service. Zoo Enterprise will include software setup which is QR code scanner and barcode scanner when they want to enter the zoo. The benefits are they can buy the tickets for entering the zoo easily, while the benefit for zoo management is they can track the number of customers at one time based on the data. Next is system drawback. When the data was being processed, there will be some overlap data which could make the data inaccurate and lead to some confusion in the system. Then there are also when the data from the one who books the ticket online with one who buy physically could overload the system data, where it need to track the number of customers at one time. And our suggestion for the improvement is a system to keep track the customer in and out should be added so that staff can manage how many customers they should be able to be in the zoo at one time to prevent congestion. In addition, feature where the staff can directly change their handle customer with another staff also should be added because there might be an uninvited event occur and instead of telling the management, they can directly change to the system. And I think that's all for me for presentation of my group project, our group project. Then thank you.